Okay, hello, welcome to Devox. So during this university we will talk about Docker, trying to introduce you this new tool, some way new tool. And as we don't want to bother you with lots of slides, even I have a few of them, we will have some demos, assuming the installation complete. So let's first introduce myself. I'm Nicolas De Loof. I'm a Java user group leader. I'm working also at CloudBees, and my daily job is to contribute on Jenkins, especially on the Git plugin, and I'm investigating Docker integration.
Good morning, my name is David. I'm freelance in the Java world. I live in Paris, France, and I use Docker every day on my work, so I hope the demo will demonstrate what you can do with it.
Yeah, because David wanted to ensure the demo is okay, so he did a last check at the hotel and crashed everything. So I have to reinstall just a few minutes ago. But something you have to know is that actually David is Iron Man, so that's not an issue for him. So let's start and talk about Docker. So be careful. It's possible when you left this room that you feel so happy that life won't feel like it used to be, because you will like to put Docker everywhere, and then you will get back to your usual job. It may hurt. It's not our fault, sorry for that. Let's guess the demo are okay, and start. So why Docker? Why this new tool? Simplest way to introduce Docker and let you understand the concept is to talk as a developer. So you write some code, want to run it as an application. You are working on a laptop. Maybe you are using Windows or macOS, things like that. As you want to go fast, you are using some lightweight servlet engine, or maybe even no servlet at all. Because you want to do some reasonable software development, you are using a continuous integration server, so some old computer put under your desk or somewhere in the cloud. You have used Ubuntu OS, so it's quick to install, some cat server, something like that. And your actual target deployment is running on some professional hardware with a Red Hat Enterprise Linux, and same for JBoss with all the certification required for a production system. And surprisingly, sometimes it fails. Even you are supposed to have these famous Java write once, run anywhere. You have some strange issues. I especially like this one about encoding. We all understand the reason of this issue, but it's always hard to diagnose. So a few years ago, we had a talk at Devox about using DevOps practice. So people introduce Vagrant to reproduce a production-like environment on your computer, so you can really test your software in his target environment. So
who's using Vagrant here in the room?
Right, a dozen of you. Okay. So let's just have a quick look. Need up. Shell. Make it a bit larger up. Sorry. So we start a VirtualBox. And my Ubuntu system. So I just changed my CSS and want to see how it's result in my website. Yes, I want to see the result. I added a background image. Hey, start. Go on, VirtualBox. Okay, we'll take a coffee.
Yes, coffee break.
Okay.
Sorry.
Okay, see you in a few minutes. Right. Still not?
Nope.
No, not yet. Another coffee. Oh, it is. Okay. At least the OS is there. I still need to start Tomcat and so on. So, right, it's working. I can have my target environment, even I'm working on macOS. But I'm not really convinced by the concept. If you look what actually VirtualBox is doing, so you have your your own computer with hardware, OS, and so on, lots of services. And you start a heavy process, named a hypervisor, so VirtualBox in our context. This software role is to emulate another computer on top of yours. Start an OS, virtualize a file system so you can come into Ubuntu or anything else. Start all the services required by this OS. Start your own application runtime, your application, and at least what you really want to do. That means see your application running. So there is some cost doing all those layers. And it's not really what I want to do on my computer. And especially if I told you about emulating hardware. Are you really trying to do such thing? Maybe you already tried to run those legacy games you had when you were a child. You can now have an emulator on your computer to play the mega system on your OS. But that's not what you do as a daily job. So actually there's a hack. The idea of a hypervisor is that you can run anything on a computer, but if you restrict a few, let's say for example we are using the same architecture as a processor, then we can make some optimization, especially we can request the processor to handle the virtualization. So we won't emulate the processor. There will be direct execution on the actual hardware. That makes VirtualBox reasonably fast. Reasonably. But that's still not what I'm looking for. I still have to start this OS. We can see it takes a few dozen seconds just to get the OS up and running. And if you look further, the idea of a virtual machine is to have a chip on top of another chip. Okay, it's possible, technically speaking, but that's not really what I want to do on my computer as a daily basis. And there are also another little problem that my application is in an incredible number of processes. If you start a VM and just do a PS to see how many processes are running on OS, you might be surprised. I just want to see this fucking CSS file update on my website. Sorry, we can cut this. And it can be worse if you really want to reproduce a target environment. You don't have just a Ubuntu server. You have a database. You have application servers with a load balancer, a distributed cache, things like that. That's required lots of VMs. And in most cases, you will just crash your host machine. So why are we using VMs? Because we use different operating systems to develop and to run the production. We might use different CPU architecture, but today most of them are running on Intel platform. We want to run multiple versions of the same application to reproduce a bug, investigate. Some want to use VM as snapshot to move the application, but that's another use case. Anyway, something you can do to make it better, as we did just targeting one CPU architecture, is to say, okay, we will target just one category of OS, one specific kernel system. We will target Linux, all flavors of Linux. That's a reasonable contract. Who of you is running an application on a Windows server, or maybe a HP UX, Solaris, FreeBSD? Oh, a few of you. Don't panic.
And Linux?
Yeah, a huge majority. So, let's see. It's yours.
Okay, so you showed us how to start an Ubuntu in less than 20 seconds. I'm going to show you how to start a Docker container. So what I'm going to do is I'm going to start just a bash shell in the context of a Debian distribution. So to do that, I use Docker run that will make it possible to run an image and turn it into a container. So we'll talk more about containers after that, but the demo is to show you how easy it is. So some magic flags. So So I'm just going to start a bash in Wheezy. So it should take a little bit less than 20 seconds. Done. Okay, so here I am inside Debian. I can look at the file system, and just to show you, I can show you the file system in my Mac. So it's really different than this one. Okay, here I'm really on the Debian. At least I'm on a Linux. I'm running on Linux. Okay, and because I am inside a container, I can do crazy stuff, like for example that. Have you tried that on your machine, or even on your VM? If you do that on your VM, you say, "Oh, I forgot to do a snapshot before. I broke everything." So you reinstall everything, or you launch your Vagrant up to recreate your VM. Here I'm going to try it on my container. Okay, so I removed everything into the bin folder, and then it's pretty much broken. Okay.
But that's a bit annoying.
Yes, it's a bit annoying, but it doesn't matter because I can just exit and start a new container, and everything is back again. You've seen how easy it is, how fast it is, and you've seen something very important with Docker is the ability to snapshot containers and to just trash them and start a new one fresh. So let's say your application is working properly in production, and then you files, or it starts creating crazy things. So you just stop your container, start it again, and it gives you some time to fix the problem. Same way, if I create a container image and I make it work on my machine, I put it on a server, it will work the same way. I give it to Nicolas, it will work the same way, because it will always start from the same state. So this was for the very simple demo of a container. Who would like to use that tomorrow at work, or Monday, on Monday? Okay, nice. So there's more demo coming.
So here is the magic. As I was told, we are using the same Linux kernel, both on the virtualized system and on the host OS. So the idea is just remove all that stuff.
I like removing stuff.
That's simple. There is still virtualized file system. That's the reason we can run Ubuntu, not actually having an Ubuntu host, but that's really that simple. And that's the reason we can run lots of them on a single machine, because you don't have all this heavyweight system to handle. Something we didn't really demonstrate here is the way Docker is managing the file system. It's based on copy and write. So as you can see, we can delete everything, and we can just revert of the file system image for our Ubuntu. For the same reason, you can just snapshot. So in Docker, known is commit, like you do with Git. You commit your container file system to a specific state that you can restart later. And all those layers are strictly read-only. You just commit change. You just do change to your file system when you're in the container. So even if you delete, you just register deletion, but the underlying file system snapshot still has the files. So that's a bonus compared to virtual machines, because you can share lots of things, especially the base image. If you are always running on the same target environment, let's say Ubuntu or CentOS or whatever, all your Docker container will share the same base layer. So you can have various systems running, Java, Node, Ruby, or whatever, but you can also have a common image to run Java. There is official Java image in the Docker repository. So you can have all your Java applications sharing all the underlying layers. And for the same reason, you can also run the same application on the same host and crash Keynote. Right.
Yeah, this sharing thing is very important, because in fact, you've seen the picture with the 10 ships on a ship, and when you work with VM, you have this problem very quickly. With Docker, you can share libraries across all your containers. So if you run, like on your machine, 10 containers with your application, with your Java application, for example, they will share the same JDK, they will share the same OS, they will share the same jars, they will share everything except the running state and memory state. And this way you can run a lot of containers on a single machine. Keynote?
Yeah, Keynote. I should use PowerPoint. Okay, let's skip this slide. Right? Don't move too fast. Okay, so far we have seen how to use container and this concept of layers on the file system. Hello? But if we have to log into our container to do some change and to commit, we can do that. But at the same DevOps conference last year, they were talking about infrastructure as code. Don't do things manually. Automate everything. Write them as recipes to reproduce your environment. We want the same.
Yes.
Okay, so let's do it. So we will use something called Dockerfile. So if you are already using Chef, Puppet, or stuff like that, you will consider that the DSL provided by Dockerfile is really simplistic, but you can at least do some significant things with it. It's a pure text file, so it's really easy to share on GitHub or whatever. So you can contribute other Dockerfile to provide fixes and so on. It's easy to reproduce on your own computer. And also, Docker will use an execution cache. That means that every time it sees the same command executed on the same order, it will just say, oh, I know the result of running that. So for example, you start from an Ubuntu image, and you install Apache. apt-get install Apache. Next time you want to build a new container with the exact same commands, Docker will just know the result of doing this. So it will be really faster. Simple way is to have a demo.
Yes. So there were a few people using Vagrant on the room. Have you seen what a Vagrant file? It's not very fun to use. When you need to install specific packages on your machine, it's not very easy. You need to learn a lot of tools. With Docker, it's much simpler. You just use something called a Dockerfile. So I'm going to show you a very simple example of a Dockerfile. It's not the minimal Docker, almost. Okay? So in fact, there's even one line that shouldn't be there.
Yeah, it was a bit complex.
So now it's only 2 lines. So you've got a Docker file, it's a simple plain file, and on your plain file you just put commands and metadata. So the first line is a metadata. It tells that you're going to build a container based on another image. Okay, so with Docker, you choose a base image, then you do your things, and this will create an image that can be used by someone else to do its things, and etc., etc. So you can have a base image for your operating system, and then you install the packages for Java, JDK, etc. So you build another image that all the Java developers will use, and you build a different one for Node.js. And from the Java image, you can then install your own applications and create one container for each application. So here I'm going to create a very simple container that will just echo hello world into the console. So this will show you how to build your own image through a descriptive file and how you can run this container and get feedback on your own terminal. So here I've got a Docker file. So I showed you 10 minutes ago how to run a container. So now I'm going to show you how to build an image. So I'm going to Docker build. I'm going to give it a name. So very often you will give this kind of name with your prefix. It's like your organization or your GitHub login, and then the name of the image. And then you can have some more information like tags, versions, but here I'm just going to stick to a standard naming. So I'm going to build an image from the current directory. So I'm saying to Docker that in this directory there is at least a Docker file that he can read and create an image from. So here, you've seen it's very quick. In fact, I'm cheating a little bit. I've run this command on my machine already one time. So the first time, Docker had to download the base image. It downloaded the base image from the Docker hub. So it took some time. Debian is about 400 megs, something like that. So it downloaded 400 megs. And on top of that, it just added one metadata that is, if you run this container, then it will echo hello world. Okay? So the first time it was very long on my machine, and then Docker realized that it could use its local cache to make it go faster, and if I run the same command again and again, it will reuse what it's already done locally on my machine. So I created an image. I can now run it. So magic flags. I give the name of the image, and that's it. The image knows what it should do. It should echo hello world.
From
hello world. Yes, it works. So you've created your first image.
Yeah, 2 demos running.
2 demos running. And that's the end of the show.
The main benefits here, if you create your Docker file incrementally, just adding commands and building to ensure everything is okay, you don't have to pay for the weight of rebuilding everything at every time. You will reuse the cache every time. So even for your company's use of Docker, you probably will always target the same operating system, always install the same middleware. So you can just share all those layers and get something really fast to build on your computer as a developer.
Yeah, I'm going to show you a little bit, a demo that is a little bit more complex, that will show you how you can install things inside your container. Okay, so I'm going to use a very simple command that people who use Linux might know. It's called cosay. So I don't have cosay on my machine. What cosay does, it will display a little co in ASCII arts that will say a message. Very important. Who knows cosay? Okay. So I'm going to use it with another command, a Linux command that is called fortune. Fortune will just give you random good fortunes sentences.
Random generator in some way.
Yes, yeah. It's like the fortune cookies. So to do that on my machine, I don't have fortune, I don't have cosay. I created another Docker file. So this one here, so there's a command section. There is a from section, so I'm starting again from Debian. I can add some metadata like who is maintaining this image.
That's a good way to add new spans from GitHub.
And then you can run commands, plain Linux commands. I think this is really a strength of Dockerfile format, is if you know Linux, it's very easy to write a Dockerfile. You just write plain Linux command with a prefix run. Each line will be run inside the container. So we'll download files, create files, delete files, configure files, and then it will run the next command. You can also put environment variables like this one. So here I'm just changing the path variable after the install to make sure that all the binaries inside USR games are in the path. And I set the command that needs to be run by Docker when I run this image. A minute ago I showed you something with a CMD prefix, and now it's entry point. So it's a little bit different. CMD is the default command that Docker will run, and entry point is the prefix. It is the command that will be run, and if you pass additional arguments during the Docker run, it will be passed to this command. Is it clear? So let's see how we build this image. Copy paste is simple. So here again, very quick. I'm going to show you what it does if I change a little bit the Docker file. For example, let's say I want to I want to install Git also.
You're missing a backslash.
What did I do?
In your Docker file, you're missing a backslash.
Oh, yes.
Complete the command.
Yes, but it's demo effect. Okay, so now I build. And here, I'll just Control-C. You will see that the first steps are taken from the cache. And this one step that I've never run on my machine after the two other steps, it needs to be really done. So it needs to really download Git.
Actually, you can see Docker don't try to understand what the apt-get is. It's just taking the full command. It didn't run this exact command before. It's not trying to do what Chef or Puppet are doing, to consider a list of package and see, oh, I already have this one, I just need to add Git. That's another level of magic. That's not his role.
Yeah, so the magic has to be in your head when you create your Docker files. You need to create groups of commands, like here, if you want it to be run once all or nothing, or you can have lots of run lines if you want to have different level of cache. It's very, very convenient where you don't know really what you need to install on your container. You know, when you're working with virtual machines, so you bootstrap a virtual machine with the OS, and then you install packages and you say, oh, I missed something. I shouldn't have taken this package, but this one. So hopefully you've got a snapshot. If you don't have a snapshot, then you need to roll back. So this is why we've got automated tool, because if you do it manually, it's really a nightmare. With Dockerfile, it looks like you're doing it manually, compared to Chef, Puppet, Ansible, or what else. But in fact, it's really not manual. It's really a very simple recipe that uses a cache to make you be really more productive. And it works very well, and it's still very, very simple. So here, I'll roll back my Dockerfile to the previous state, save it, and do the Docker build. And here, it realizes that everything is on cache. Okay? So I can experiment with my Dockerfile, and the cache is here to make it go faster, as fast as possible. And now I've got a very interesting application that I can run this way. You wish you had that on your laptop, don't you?
Yeah, you have to share this image.
Okay, so I'm not sure you want to put that into production tomorrow, but at least it shows you that with Docker, you can start from a base image, you can install packages, and you can set into the container the command that needs to be run when you run this container in production. And this way, you've seen that it's very easy to create your own containers.
Right. So now you know Docker. The question is, who will use it? So developers, for sure, as we are. Maybe you notice we are not running actually Linux systems, but we can do some Docker stuff. We are using a hack named boot to Docker. It's actually one virtual machine, a very light one, that you install once, you start it, and it will host all your Docker containers. So you can just install it and forget until it crashes. So. But that's a reasonable way to have Docker, even if you are running Windows or macOS.
Yes, so really on a Mac or Windows, you've got a level of indirection. So you don't run Linux processes directly. It's obvious. So you need this very small VM. And so it needs a little bit of thinking compared to the guys who are working on Linux, because they just run containers and they access the containers from localhost. And here you run them on a different machine inside your own machine on the VM. So it's a little bit different. And also on Windows, it's a little bit...
It's a Windows.
It's Windows. Who's working on Windows? Okay, so good luck, guys. It's coming, it's getting better.
So, something which I can try quickly using Docker is just if you want to test something, there is lots of things you will learn during this week. You want it to get installed, up and running on your computer in a few minutes. So, first option is to read the documentation on installing the exact version you are using on your specific environment. with all prerequisites and so on. You have to cross finger to expect the installation documentation is up to date. Sometimes you can spend hours. Also, the other option is just to do Docker run my middleware, Docker run MySQL, Docker run MongoDB, things like that. And you have it up and running. You don't have to learn the installation before you start using the tool. Maybe later you will want to install by yourself or build your own Docker file with your own rules, but that's another story. You can really get fast to test things. The other use case is the one we used for the introduction, is just to have the exact same environment in your developer workstation. So no more, I don't understand it works on my machine. So the image you're running on your computer is the exact same one you are sharing with your colleague and maybe running on production.
Who've said it works on my machine already? Yeah. So was it the fault of the production or developers? Production?
Something also we demonstrated here is that you really can fully replace your developer environment setup document. I guess you all have such a document in your company explaining which version of Java, of Maven, of Eclipse, or whatever need to be installed on the developer workstation. Or maybe you are already running on such a constrained environment that someone else is installing them for you and you can't upgrade everything. But anyway, you use now, as a Java developer, when you check out project, to just try running Maven install. So sometimes it's not using Maven, but that's something you used to do because that's becoming a de facto standard. But now, even Java developers don't just do Java. They need some JavaScript, CoffeeScript, whatever script, or other stuff. They need some test environment. So we can see some open source project with some complex setups to now come with a Docker file and tell people, okay, you want to contribute. Check out the project, do your change, and build this container. It will get all the environment, run the test for you, and tell you if everything is okay. So you have the full development environment set up as a Docker container.
Just if somebody has lots of time to waste and lots of machines, it would be interesting to fork or to clone all the Java projects on GitHub that are using Maven, and just try a plain Maven build, Maven install. And I'm pretty sure that maybe 80% of the projects won't build, because you don't have the correct version of Maven, you need to configure the settings.xml, it needs you to install Node before because it will use Bower or whatever. So I'm pretty sure that more and more Java projects using Maven don't build if you just clone and install. And one thing that I think Docker will do is it will make it possible to git clone, Docker build, Docker run on all the projects.
Right. Oh. Let's show you. So git clone, Docker build, Docker run. Do it.
Git clone, it's done already. Docker build, I've got a small alias that will show you what it does. It will do just a plain Docker build. So now when you see db, it's a Docker build inside the current directory with the name, my name, / the name of the folder. Okay, it's just I'm lazy. So here, I've got a Docker file that will do a lot of things. We're going to look at the Docker file. But what I want you to remember is my project, it's a Java project. There's the src main Java test, etc. There's the pom.xml, and there is a Docker file at the root of my folder. And if somebody clones my project and do a Docker build, it will work. It will just work. It will build the project, and the project we will build inside a container. It will create an image that is ready to run. If you run it, it just runs. Okay? So here, this is something very important. It will work for Java Maven project, but it will work for things much more exotic. For example, Docker. If you want to clone Docker and build it, it works this way. It will create a container from the Docker file, and inside the container, it is able to compile Docker, to run the tests, to cross-compile it for macOS, Windows, Linux. Windows, yeah?
Yeah. FreeBSD and so on.
FreeBSD, etc. So everything is inside the project, and if you just git clone, Docker build, or I don't know, it's a little bit more complicated.
Yeah, there is some extra arguments, but okay.
But
that's the
you
main
pass
idea.
the arguments and it works, okay? So let's see what the Docker file looks like. We'll do that this way. So here I changed the base image I use for my container. It's a base image I created that is an image that contains Maven. And this image is based on another image that contains Java 8. And this image is based on an image called BusyBox that is a very simplistic Linux distribution that is something like 10 megs big. So the whole Maven image is something like 250 megs, 300 megs, I think, something like that.
Yeah, the official Java image on Docker Hub is already 500.
Yes.
So.
Yeah. My own Java 8 image on the hub is smaller than the JDK. Think about it. So I set the base image, and then I set the working dir. All the command that will be in my doc file after the work dir command will run inside home jug folder. Then here it's a trick to do warm up. We don't need that. Just look at this. So here I set the environment for my container. So I set some variables, production mode true, memory 4. I add a metadata to say that my container is going to run something that will open a port on the 8080 port. So in fact, it will start a web server on the 8080 port. And I set the default command inside my container. So it will be plain java -jar to run my application. Okay, so here I set all the metadata, and then this line is very important. I take all the sources from current folder and copy them, add them inside the container. Okay, so if you go back to my sources, I've got my sources, a Docker file, and when I build it, it just reads the Docker file, and at some point, it will take all the sources, copy them inside the container. And then, it will run Maven. So this image, what it does, in fact, is it's auto-building the sources for my project with the exact command that I need for my project. This one here will not do a plain clean install, but a verify dependency, copy dependency, skip test.
Because you don't like tests.
Yes, I do, but not here. So that is it. And when I run it, it just works on any machine with Docker. And then, I show you, I can run it. And it works. Do I show what it does? Okay. So it's very funny because if I go to localhost 8080, it doesn't work. Okay. So I've started something on port 8080 and it doesn't work. Why?
Demo effect, maybe?
No, not this one.
Not this time.
Do you have an ID? Boot to Docker. Somebody said boot to Docker, but before that? Yes, so we talked about containers, but we didn't really say what's going on inside and outside the container. By default, the container is pretty much closed. It has access to the world outside, but nobody can reach the inside of the container. So if the container is starting a web application inside the container, on my machine, I cannot connect to this port. So I need to really tell Docker, when I run, to map the port to a visible port. maybe the same one, or maybe a different one. Let's use a different one. Here, I think I can do that. No. So here, there's the problem with boot to Docker. We said that on a Macintosh, on a Mac, when you run Docker, you run it inside a very small VM. So this process, this Java process, is running inside a VM, so it's not reachable from localhost. It's reachable from the IP address of the VM. On Linux, this will work. On a Mac, you need to put here the IP of your Docker VM. I want to see that on the big screen. Oh, no, blue. Oh, no, yellow. Okay, so it works. And just to show you that it's really my container that is doing this, I'm going to cut it. And the application is down. Okay? So very easy to run, because it was also very easy to build. And I think that on Monday, when you start working with Docker, one of the first things you should try to do is try to build your own application with Docker and see how easy it is. And also, maybe it will show you how many dependencies you didn't know you even had. Dependencies on the Java version, dependencies of Maven, dependencies of that or that config file. So here you just really declare all the dependencies and it will work on all the machines, every machine.
Just I want to remember from this demo using the mapping of the port from inside and outside the container. You can see you can do some translation between the outside world and the container. So for this reason, you can have lots of container runnings, all the same image, but with distinct ports. We'll talk about this later, but wanted to point out this data.
I can show that maybe? Just
run
in daemon. So I'm going to shoot the application as a daemon. So it will go on in the background. So I can run a couple more.
Right. We are trying to reproduce our cluster with a dozen of nodes.
Okay. So here I've got maybe a dozen Java process running. They're all running on port 8080, but inside the container. Outside the container, they are reachable through a different port that you can see here. Okay? So this makes it possible to run a whole cluster on your machine. And then if you have a proxy in front of this cluster, you can really reproduce your production environment very easily. Yes, very easily. Right.
So we talk about reference environment. Another way to use Docker I've seen so far is to use it as a bug reproduction system. Because if you are able to reproduce a bug inside a Docker container, something is going strange, maybe there is some random case happening, then just commit the container. It will actually pause the container and do a snapshot. And now you have a binary image of your container with the bug that you can store and share with the development team that can just restart the container and investigate. And they can restart as many times they need to try to understand what happened so we end up in this very specific state. So we talk about developers, now we'll talk about tester with a very nice shirt.
Can you go back?
Yeah, it's cool, no? So, when you want to test, you need test resources. You need database, you need middlewares. So, using Docker is a very simple way to get them and just drop them after use. I know people using Docker, for example, they have their own MySQL Docker image. What are we talking about? Yeah, about testing. So they are using their own MySQL image, and so they have created a container that has the reference data in this database. So as a developer, or as a tester, I can just pick up this Docker image, and I have a database running everything needed for my application with all the reference state. And if you don't want to run tests manually, you can ask the butler to do it for you. And so I will show you how it looks, because David don't like Jenkins, so that's my turn. So
who likes Jenkins here?
Yeah, thank you.
Who doesn't? Beer for you. 2 beers.
So I will show you a small plugin I've developed during the Docker Hack Day, if Jenkins didn't crash in the meantime. Question is to know what you like.
Yeah, if you pay me a beer, I will tell you.
So the idea of this plugin is to say, okay, I'm using a plain Jenkins job. I just restricting it to run on a set of slaves, of build slaves that are Docker enabled. So I've created a label for it. So I'm taking some Git repository. And I just have this environment setting, I want this build to run inside a container. So I can just say, okay, just run it inside Ubuntu. That's what we did manually at the beginning. Or I can say, okay, I already have a Docker file to define all my build environment. So please use it and run my build inside this environment. And then I'm doing some very interesting stuff with hello world, running a shell script, and so on. So, yes. If I go back, run it.
Oh, you're French.
Yeah, I should have switched. Did you notice we are French? So, as you can see here, there's some magic using Docker exec. So I'm bootstrapping inside the container, the build system. And so running my hello Docker, I'm doing ls-rl. So I can see the content of a typical Ubuntu system, because this Docker file is configured to use Debian, sorry, not Ubuntu. I can change it. Let's say, you have sent to us? Yeah, I think so. So I decide I don't like Debian. I will switch my project to run as a reference on CentOS. So the next time my build come back. Next time I will execute my build. It will take a little more time, maybe, because that's too fast. Because my plugin noticed that something changed in the Docker file just after it gets the latest Git commit. Say, oh, this Docker file changed. I need to rebuild a container to host the build. And so it will show you that we are not anymore on Debian. Typically, Debian don't have a games directory or a Gopher one, but I still have my hello Docker. So I can easily switch from one target environment to another. So that's a very basic hello Docker I wanted to set up during the Docker Hack Day last week. And I worked with Johan, that is not here today, but his goal was to be able to run some Debian packaging, but not without Debian system running. So if some of you know about Debian, it's about DKPG, whatever, builds package, and so on. So if you are running on Debian, it's really easy. If you want to do it on a MacBook, it's possible. You have to do some port install to have all the related tools, and you're not really confident about the result. But you can use Docker for this. And here's the ID. Is not this one, sorry. Here is the ID. Is just that this project, we run a build script like if I was on a plain Debian system. Just configure to use a specific Docker container defined from my Docker file. So Docker file is, here you move to a specific folder to make things clear. So I have a Docker file that will install some prerequisites, but that's off. So the next step will be to be able to have the same project to build package for both Debian, Red Hat, whatever else, Arch Linux or what we want, all of them with a Docker file. and just ask Jenkins, okay, build all the system package for me. I don't want to do some crazy cross-system compilations on packaging stuff. I just want to do all of them in a container and just get the binary package. Right. So
you could do that with VMs, but it's much faster, simpler, declarative.
And especially if you are already using such a Docker file on a developer workstation with all prerequisites, you just reuse it on your CI.
Okay, that's the moment where Nicolas wants you to vote for his project.
Yeah, you have to work a bit. So you know there's Wi-Fi here, you all have a computer with you, and I'm missing, I think, something like 100 votes to get my free ticket to Amsterdam in December. So please go to this page and tweet like Google plus okidoki, so I get extra votes. Please do.
If you like Jenkins, you have to vote. If you don't like Jenkins, you don't.
If you like me, you have to vote. Yeah. If you like David, you have to vote. If you like Iron Man, you have to vote. If you hate Iron Man, you have to vote. Okay. So we will stop. We will stop until everybody here has voted.
Can you show the page with the votes?
All right. Okay. Let's go. You also can use Docker in a testing environment for all about advanced testing, let's say QA and so on. Everything about functional testing. For example, you want to run your acceptance test shoot. You need application running for a few minutes. Use a Docker container. You want to execute some BDD, it's just the next room if you want to learn about BDD, on Cucumber or so on. You need some infrastructure to host your Cucumber server or Selenium stuff. Just use a container. You want to do some performance testing, so be careful. That won't be equivalent to a production system, but have you seen we can have a cluster of our application running on a single node? They are all isolated, so you can test everything about synchronization between nodes, distributed cache, things like that, just using Docker from a very lightweight point of view. So the interesting part here is to see how the performance evolves during the project life, not the actual result of performance, because it's not strictly equivalent to a production system.
Yeah, and I do more and more testing inside Docker. It's very easy to set up an environment with things you don't want to install on your machines. You really don't want to install Ruby because you don't know which version of Ruby. There's only one installed, and will it crash all my Ruby applications? Nightmare. So you just create a doc file, start from a fresh Debian, install Ruby, you choose the version you want, and that's it. And then you just trash the container. Very easy, very quick, and you're really focused on what you want to do and not on all the problems and all the things that are already there on your machine. This morning I crashed my whole test folder with all my Docker containers because I have something very strange, but it was very easy to recreate everything from the Docker files.
Right, who else can use Docker? Your sales team. Yes, they can. Surprising, no? At CloudBees, the people that use Docker most are our salespeople, because we are developing a high availability cluster-based version of Jenkins. So when they have a call with a customer, they can't really have a dozen machines on Amazon up and running on a stable state. They are using Docker to have everything local on a known state that they know it will work, whatever comes on the Wi-Fi. That's a very good sample to demonstrate how Docker is easy to use from a user point of view. To just bootstrap an environment, you don't have to know exactly the bits that are running. You don't know some extra skill. We created a shell script so that they don't have to run the Docker run --rm, blah, 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 blah. So they just run demo.sh. Hop, the demo is up and running in a few seconds. And some of those demos we can also share with partners. So even from a business point of view, that's really a good tool to share.
Yeah, and as you've seen at the beginning, when I remove everything in a bin folder, if everything goes wrong during the demo, you just stop it and start it again. And this is the kind of things that salespeople really like.
Exactly. And production can also use Docker, right? We will talk about this in more detail after the pause. But anyway, lots of Java developers consider that creating a WAR archive and some documentation for installation is the end of the project. And that's not strictly true. Especially as a sysadmin, when you get some URL to some Nexus server telling, okay, we have deployed the last version of the application, and we have a 30-page the documentation to explain how to install. Especially such document used to have some system commands, where Word has the good idea to replace the small dash with a larger dash. Did you already have this issue? It's a fun one. Huh? Yeah, so everything crashed, and so sysadmin hate Java developers, and so the other way is right. So, so far, Docker is the best DevOps tools I found, because we used to act this way. Okay, we have committed the tag to the repository, we can go on weekend, the application is ready. But there is someone during the weekend that needs to install it and push into production. Oh, sorry, not this one. So when we talk about DevOps with people, there is a lot of developers that are telling, yeah, I'm a DevOps, I'm root on the system, and so DevOps is just about doing stuff on servers, and woohoo. Lots of us are reasoning this way. And on the opposite side, you are more sysadmin people that tell, no, nobody change anything to my server without using a chef recipe. Because that's the way DevOps teams are working. You need to test everything before you change something on the production server. So it's not really flexible. So you have to make those people talk together. That's not so easy. A good point provided by Docker is that you will separate concern of both of people. A concrete sample I had on an application I developed was we wanted to have some logs. That makes sense. So we were just we have configured log4j to dump log file on a var log file system. And we learned very late in the project life that on the production system, those logs have to be backed up. That makes sense? And for this to work, they have to be written on a very specific directory with some IDs that are specific to the application running that we don't know until the application is actually deployed to production. So you end up with lots of highly configurable log4j file system with a system variable replacement and things like that.
Yes, yes. Who's already developed something like a Spring application with different XML configurations? You switch which one you use depending on a system parameter, and so it tells where the logs are, which port to use.
You had a good example with the environment production on dev on your Docker file. Yeah. That's a typical Java framework consideration to say, okay, I want to switch from various environments because when I run in development, that's not the same as running in production. Yeah.
So now with Docker, you just start on port 8080. That's it. You don't configure anything about the port, about the files.
Same for files, yeah.
You just write where you want to write inside the container. And when you run the container in production, somebody can decide to change the port. Somebody can decide to change the directories where you write the logs or where you read the configuration files. Everything can be decided very late in the project and can be decided by the developer or by the production or by both, but it doesn't have to be in your code. This is really a huge shift that you have to do. It will simplify your code a lot, because even if you need to start a cluster, you've seen that I can start a cluster with 10 Java process running on port 8080 on a single machine. It will be the same in production. So you don't have to increment the port or whatever. This will be done at the runtime. Huge shift.
So your ops role now is to manage all the infrastructure, to monitor your application, to back up everything, to ensure everything is working fine, but not to know every bit or implementation details of your application, especially which specific update or JDK 7 you are using that don't strictly match the production platform. They just run a Docker container. Developer, on his way, can just use maybe the simplest possible solution, or at least the one he likes, if you really want to do some JSF, all yours. And you don't have constraints about configuration. So typically, your application will just start on the port you want, and you can hard-code it. You just have to forget everything you have learned for the last 10 years about configuration, flexibility, Spring profile, system properties, environment, and so on. Just put everything hard-coded, port,
abstract configuration, template, factory, singleton.
Something like that, exactly. So your file system directory are hard-coded. Your logs are just sent to the console. That's the way you are working as a developer. Just see everything happening. Just create your containers this way. And the production team will use Docker log or something comparable to capture all those logs and do what they need to do with it. And if you put all those bricks together, you can build a continuous delivery chain. So simplest way, clearly, is to use Jenkins for that. Or you also can, here is a sample, it's a slide from the DockerCon where eBay people were explaining the way they're working. And so they are using Jenkins, and they are using Docker to create Jenkins slaves on demand. So there are always a fresh new Jenkins slave. And inside this Docker container, they will run another Docker build. So a nested Docker inside Docker, because they are using Docker to create the slave, then Docker to build the project, and maybe this one also needs to create Docker, because you can do such thing.
You said Docker. Right?
Yeah, let's see how it works, because it's something really crazy.
Yeah. You all know the Fibonacci numbers? Fibonacci numbers? Yeah. Oh.
Okay.
So you're just sleeping. Okay. I wanted to play a little bit with Docker running inside Docker. So why would you do that? So eBay, they're doing this to isolate even more their continuous integration line. So sometimes you want to create, you want to define the context in which you want to run Docker. And then inside that Docker, you can run containers. So I tried to do a very simple project to compute the Fibonacci numbers using Docker inside Docker. So just give me some time to remember how to do that. Okay, so for example, here I've got a very long command line, and you need to remember two things. I'm going to ask what is the first Fibonacci number, and I'm using Docker -- privileged to be able to run Docker inside Docker. So Fibonacci of 0 is, this one I didn't prepare. Okay, so we're going to see what it does when I run an image that I don't have on my machine. It needs to be downloaded. Downloaded from where? Here is downloaded from the Docker Hub. It's a website where you can host, everybody can host their images. You can host your public images, you can host your private images, but then it's you need to pay. Or you can host your own hub in your own network or on the cloud. There's a lot of containers that you can use to host your own hub. So here, it will just download my image. So what is very interesting is you can see that it will download all the layers of my image, because my image has a base image, then I installed things, and then I installed things on top of that, and each installation is a layer, and each layer I can have it on my machine or not. And if I don't have it on my machine, it is downloaded from the hub. So here the internet is not very quick, so it will download all the layers. I think it's pretty much the last one. No?
Or maybe it's time for a little joke?
No.
Okay.
No joke.
So there were 2 eggs on a frying pan, and one of them is saying, "Oh my God, it's getting so hot." The other one answered, "Ah, a speaking egg!" Okay.
Please don't applaud, it's crazy.
Not completed yet? Want another?
No, maybe we can take questions after that, but it's done. Okay, so questions just after that. So when I ask for Fibonacci number 0, it's easy, it's just 0. 1, it's just 1. And 2, it's a little bit more complicated because if I want to know the third Fibonacci number, I just ask to the one before and the one
n-1
n-1 and n-2. So Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. And here it will run a Docker image that inside will spawn 2 Docker daemons that will each run 1 Docker image, and it will get 0 from 1 Docker image, 1 will do the sum and will give me the sum. Ooh. So a little bit slower because it's running Docker twice inside my Docker.
Yeah.
So 1 plus 0 is 1.
It's actually running a container that will host a Docker daemon itself. It's not just free containers, it's really nested containers.
Yes. So Fibonacci of 3 is Fibonacci of 2 plus Fibonacci of 1. So it's Fibonacci of 1 plus Fibonacci of 1 plus Fibonacci of 0. Okay, so I will stop at 4 maybe because it will start to take a lot of time. At the beginning, it was just to make sure that I wanted to. Nicolas was doing his presentation about eBay, saying that eBay was running Docker inside Docker inside Docker, and that's it. Just 3 levels. I said, okay, I can do 4 and 5 and 7, and I tried more. And in fact, if you've got a machine that is quick enough, you can do Fibonacci 10 in about half an hour or maybe an hour.
There is better ways.
There are better ways, even with Docker inside Docker. Here it's really the slow path, but it's the most one. No, there's another path where you can run Docker and inside KVM, and then inside KVM you run Docker extra. So you can do that. You don't really want to do that, but you can. Should we take some questions before the pause?
Yeah, we'll take a small pause and can take some questions before if you want.
There's a question there.
If every change to the Docker file is persistent to be a layer, how do you handle if apt gets a new version if I have to upgrade to a new version of the JVM?
Okay, so
the question is, considering that Docker file with cache, every execution, what happens if there is an update to a package that I already apt-get? So Docker knows the result of running apt-get Apache that I ran 2 months ago and won't consider the new version that has just been published. That's
yes.
Right?
In fact, Docker considers that the same command will give you the same result, which is wrong, of course. But it says, okay, I will take this shortcut, and if the writer knows it's wrong, he can change his Docker file. So, for example, here, what I do is, with the same command, I do an update and I do an install. If I add another package to install, it will trigger the re-execution of the whole line. So it will trigger an execution of update again. Okay? So it will just invalidate the cache for the whole line, so the update and the install. So each time you need to install a new package, maybe you are just playing with the tool and you decide to put it on another line, up like this, apt-get install git. But here, this will be taken from cache, and this will take maybe an old version from the cache. So you might want to do that when you create your Docker file, when you play with it, and then if you want to make it really bulletproof, you should group the update and the installs on the same line.
And use some specific version, lots of software package, or maybe even NPM and things like that. Just consider that when you put a package name, it's just the latest. So latest involved in time, by definition. So you are encouraged to always specify an exact version.
Here, for example, for Git, I specify really the version I want, because I know that the one before was buggy, the one after I don't want. So here, I can be sure that it's this version that will be taken.
And the other option is to run the Docker build with option -- no cache. if you want to create your production container image, so that you ensure that everything is creating from scratch with all the layers of today. That's another option.
So there's a lot of things you can do, but there's also a lot of things you need to think about. But you will learn them very quickly when you play with Docker. Does it answer the question? Or?
The question?
More or less, no? Not,
Okay.
So what about Windows inside Docker?
What about Windows inside Docker? There is some promise to have a Docker equivalent on the next version of Windows Server. So wait and see. But today you only can host Linux. That's the principle. People from BSD, from IBM are working with Docker team to try to implement the same principle on a common API. Typically, FreeBSD already have BSD jails, so can do something very comparable. Just need to implement the API. So wait and see.
Yeah, right now on Windows you can really just run the Docker daemon. So it's the
Docker client.
No, you run the Docker daemon inside a VM with boot to Docker, and even the client, the one that I use when I type Docker here on my Mac, doesn't work. It doesn't work yet on Windows. So you just have boot to Docker. It's a Linux VM. Inside there's the Docker daemon running, and you SSH into the Docker, and you can play with Docker. But it's really play. It's really difficult to do some real work on Windows. On the Mac, you can run the client on your machines, the Docker on boot to Docker. It's quite good.
Yeah. So with recent version, it's sharing your home directory from your host system and the Docker boot to Docker VM. So you can use your standard IDE environment to edit the code and just build or execute inside the boot to Docker VM. Yeah. So it's a reasonable compromise.
Yeah. As long as your files are inside your home directory, and as long as you use the IP address of the boot to Docker,
you don't have symlinks or things like that are a little bit complex to address. Right. So, last question?
No. Is it possible to run multiple shells to the same container?
Right.
Is it possible to run multiple shells inside the same container?
Yeah, the same container, for example, to watch logs of different instances of your environment.
Docker exec, if you want to show it.
Yeah.
Just run the web application container in daemon mode, maybe, or another. So we have application running in a container, running the Java process.
So here I can see that I can do a Docker PS to see all my running processes. So I can Docker kill them, stop them, or I can even exec inside a new command inside the container. So for example, I can
with the TTY.
I can run a bash inside the existing container.
I think that's before the container ID.
I think.
Fade. You are on BusyBox?
Oh yes, I'm on BusyBox.
Just a SH then. Small is beautiful. Right.
Okay, so here I'm running inside the same container. I don't have that. Okay, I can see that there's a Java process running. In fact, it's basically the only process running. There's the SH I just started, and there is the Java process. So now I can list the logs, tail the logs, whatever.
Right.
So I can really re-enter inside a running container. In fact, what I'm doing is I'm entering into the namespace of the container. And so when a container is running a process, it's running the process into its own namespace so that it doesn't know all the other processes. And what I'm doing is I'm entering into the same namespace. And I can run commands. This is what you're using on your...
That's what I'm using on Okidoki. It's actually running a container for the whole build and killing it at the end. So you can start processes if you need inside the container. And each build step will just attach a new process to the container, do some stuff. And when it completes, the container just follow up until the end of the build. Right, let's have a pause for, let's say, 1 quarter. And
half an hour, you said?
One quarter.
One quarter.
Yeah.
15 minutes?
Yeah. And
if you want to ask us question during the break, I'm there.
And for those of you that want to vote for Okidoki, I also have Docker t-shirts. So please come here. I also have stickers if you like. So you're welcome.
See you in 15 minutes.
Faut juste que je regarde pour Stéphane.
Some people find it hard to see. Oh, yes, they do. Yes, they do. Yeah. But every time you look at me, no doubt about it, you and me, we got. Can't stop you now. Can't hold it down. If I needed to, I'd give it all up. Oh, don't ask for more. I'm living for. Oh, if you feel love, put your hands together like this, y'all. Put your hands together. Put your hands together like this, y'all. The way that I feel about you, girl, I wouldn't trade it. No, never. For all of the money in the world, 'cause I can feel it. You and me, we got. Can't stop you now. Can't hold it down. If I needed to, I'd give it all up. Oh, don't ask for more. I'm living for. Oh, if you feel love, put your hands together like this, y'all. Put your hands together like this, y'all. Now I wake up in the morning and feel you next to me. I know I'm blessed from above, 'cause it's all so clear to see that I got real love. Yes, I got real love. Can't stop me now. Can't hold it down. If I needed to, I'd give it all up. Oh, don't ask for more. I'm living for. Oh, the love I got for my people, the love I got for my family, the love I got for my music, the love I got for you. This is real love. Oh, this is real love. Put your hands together like this, y'all. 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 acting like a clown till our parents told us to stop. I'll treasure these moments for the rest of my days, and think of my friends in so many ways. Don't you know these are the good times, the times of our lives. Enjoy the good times that give us the drive to go on to good times. Not thinking about tomorrow or what may come. No, 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 no. Summer break when we were 17, school had made us go insane. So we decided to go on a trip and jumped in the van to Spain. Why is it these moments always go so fast? While all I want is for them to last. Don't you know these are the good times, the times of our lives. Enjoy the good times that give us the drive to go on to good times. Not thinking about tomorrow. Forget about your sorrow or what may come. We all had our troubles in life, but that won't make us give up. 'Cause I feel like bubbles tonight and the bottle's about to pop. 'Cause we should enjoy our happiness. 'Cause these are the times I don't want to miss. Don't you know these are the good times, the times of our lives. Enjoy the good times that give us the drive to go on to good times. Not thinking about You're not that, you're not that, you're not that beautiful. You took the best of me, don't seem to need the rest of me. When will you realize that I'm still around? You've been ignoring me for quite a little, boring me, while you've been compromising all over town. Why would you think of making up? I guess you heard we're breaking up. Night after night I'm on my own, now you're stalking me. Where did you get that attitude? I guess I'm just not in the mood. This is the end of the story for me. Come on now, why don't you get a clue? This love affair is through. All I can say to you is you're not that beautiful. Why would I want to stay? I can't go on this way. All that I've got to say is you're not that beautiful. Been working day and night, been trying hard to get it right, while all my needs and dreams get put on the shelf. Love ain't no 9 to 5, ain't gonna be your pretty wife if I don't get a little love for myself. Why would you think of making up? I guess you heard we're breaking up. Night after night I'm on my own, now you're stalking me. Where did you get that attitude? I guess I'm just not in the mood. This is the end of the story for me. Come on now, why don't you get a clue? This love affair is through. All I can say to you is you're not that beautiful. Why would I want to stay? I can't go on this way. All that I've got to say is you're not that beautiful. You're not that, you're not that, you're not that beautiful. You're not that, you're not that, you're not that beautiful. Don't you get a clue? This love affair is through. All I can say to you is you're not that beautiful. Why would I want to stay? I can't go on this way. All that I got to say is you're not that beautiful. Why don't you get a clue? This love affair is through. All I can say to you is you're not that beautiful. Why would I want to stay? I can't go on this way. All that I got to say is you're not that beautiful.
Here we go. Right. So let's follow up. So I quickly told you the way eBay did to integrate Docker. So if you don't like Jenkins, some people here don't like Jenkins, I don't understand why, you can do it fully from command line. There is a pattern, an emerging pattern in Docker, because we had a discussion earlier about David's image to have Java on BusyBox with just minimal environment, so it's very lightweight. And on the opposite, you have to install Maven, Java, Git, Bower, and so on, just to build from source your application. So there is two aspects where you can use Docker. One is to have all the tools installed to produce some binary, and the other is to have your target environment as lightweight as possible. And you have to chain them together some way. So what we see so far is that people are using a base Docker file with some Ubuntu or something where you can easily install stuff. When you build this image, it will compile everything, create the binary. And when you run this image, it will output either just the binary or a full context that is ready for the next step of your pipeline. And this next step itself is also a Docker file that will take the binary and place them in your production environment. And you can imagine another step still using Docker that will run your acceptance test and things like that. Maybe the simplest option is to have a basic demo.
Yeah. So to rephrase it, we've seen earlier a Docker file that starts from your sources here and builds the Java application from the sources and also tells what command to run when you run the Java application. So you're really doing two things with a single Docker file. You're saying how to build the application and how to run it. And because you're using a single image, this image at runtime will contain all the dependencies that you needed at build time. So it's really, if you deploy this image in production, the servers will need to download a bigger image, just because you also included the build dependencies, but also you included all the intermediate build artifacts. So let's say you created, you built a Java application from sources. It will download the universe with Maven. Everything is into the M2 repo, and you don't need that for running the application. You just need a couple of dependencies, your own jars, and that's it. So really, if you keep a doc file like this one, the image will be very big. And it's even worse with things like when you work with C or C++, you need to install a lot of build tools, libraries, and things just to build a static binary. And at the end, the static binary is self-contained, and you would really like to have another image with maybe another operating system base, and this binary, and maybe a couple of files, and this will be your run image. So you would have a build image and a run image. And as Nicolas said, there is a common pattern to go from a build image to a run image. I'm going to try to show you how we can do that. There are different ways to do that. What I'm going to do is I'm going to use two Docker files, one for the build and one for the run, one for the money. Okay, so here it's about the same Docker file as before. I have a Docker file based on Maven. Here it's just a hack. Here I removed all my run environment variables because I don't need them. I add all the sources, and I add a new Docker file with the sources. I run my build, and after my build, what I'm saying is this Docker file, if we run it, it will not run the application. It will just dump all my target folder into the standard output. So in fact, it will dump everything that I built into the standard output. And I need to have somebody reading from the standard input and putting it into another container. Do you follow me? And who will do that? It will be the other image. Okay. The other image here is not a Maven image, it's just a Java 8 image, smaller. Here, it will add everything. Here, it's not the current directory that I will read. It's what the other build image will pass me through the standard input. So one build image will generate a tar file, will pass it to the other image that will just read everything, put it into HomeJUG, set up the run environment, and set up the run command. And if I run the two Docker build, run, and another build, it will create a very small image. Very complicated. But we can see what it does. So let's try to build the first image. So here I don't have it in cache, so it's going to take some time. So it's going to really. Oh no, I've got a little bit of cache.
Oh, I had a joke if you want.
No. So it's going to build my application. I don't know if yes. Okay, so it created a container that if I run it, will dump all my Java files, my jar files, into the standard output. So it won't be pretty. Okay, so this is a tar file. Okay, so you know it. Okay, stop. So this is it. My image. If I run it, it doesn't run the application. It just dumps the binaries of my application. And this, I can pipe it into another container. Let's see how I do that. I thought I had the command line, but no. Okay. So Docker run. Let's pipe it into another Docker build. I'm going to give it a name, small. And I'm not saying read into current directory, but I'm saying read into standard input. Okay? So here, one container, when it runs, will pipe into the other build process. What did I say? Qu'est-ce que je fais? Voilà, what I did.
Tu mets un pipe à la place du...
Sorry. Okay, so it used to work. And it's one problem with this pattern, it's quite complicated to debug. So what we can do is we can try to decompose things, and we can try to run and dump it into another file, a tar file. So let's call it binaries. Okay. Oh, what's going on? Okay. Problem on my machine. I don't know what. Something is going on. Okay, so here I created, here we are. So I created a tar file, okay? So let's put it into another folder and see what's inside, just to make sure that, okay, it doesn't work. Okay.
Okay, let's
broken demo. Broken demo. Thank you very much.
This used to work. But you have the main concept. Anyway, so where will we run Docker? You probably have read lots of buzz about Docker from cloud companies. That's a place where you already can deploy Docker. There's lots of them. Oh, I should remove our card because they just stop the service. They have been acquired by Docker. You also can use Docker to run on Raspberry Pi. I don't have it here, but that's a good sample to demonstrate how Docker is, how lightweight Docker is, because you can really run a Debian, a Raspbian image on Raspberry Pi running Arch Linux, for example. That's a little slower, but it's fun. And for sure, you can use it on premises. So that was, if you have seen DockerCon videos, there is lots of big actors already using Docker, but we have few noise about them. So on the cloud, there is, I would say, two categories of platform as a service. Some of them just tell you, we will handle everything, just push your source code, we build it, we package, we run. That's typically the Heroku approach. Some just tell you, okay, build your Docker image and we can run it for you. So both make sense depending on your own internal process. So let's talk about Google, and then you are the Google developer expert. So it's a...
You can give me 10 seconds?
Yeah, I can do we want a little joke. Which side does the cat have more hairs? On the outside. Okay, about Google. One part of Docker, one technology Docker is using is control groups. The other is Linux namespace. All those technical stuff has been introduced in Linux kernel for a decade, and typically control groups was contributed by Google in 2006 or something like that. So it's not something new for them. And they are using not Docker but containers for a while with their own stuff, and so they are really interested in Docker and contributing a lot. So. Want to talk about managed VM maybe? Or better to...
Yes, I can talk about managed VM.
Sure.
So who knows App Engine on the Google Cloud? Okay, so App Engine is the PaaS of Google. So you just write your application code and Google takes care about everything else. So the scaling, proxy, memcache, everything. So you just push your application in production, and if nobody is using your application, you don't pay anything, and if a lot of people use your application, it scales automatically. The only downside of that is you need to write for a very specific version of a framework. So you can write for your application for Java 7, but you need to get rid of a lot of APIs that rely on file system, that rely on things like AWT, which are not safe to run inside the App Engine containers. So they just tell you you can use this version of Java and it's a trimmed down version. Or you can do it in Python, Go, PHP now. But each time you've got constraints and you cannot do everything you want inside your application. So this is where they decided to support Docker. Docker, so you have the sources of your application, but also you describe the runtime environment into a Docker file. And App Engine will spawn VMs to host your own Docker containers. So this way, you don't have any limitations. You can do anything you want, native code, use Java 8, Java 9, whatever. You can make it run in App Engine, and App Engine will take care of the caching, will take care of the scaling. It's not yet there. It's available in alpha or beta version, I think. But the idea is everything will run into Docker containers, and it will scale the same way as App Engine scales. In the meantime,
there's a talk about Docker container on App Engine. It's on Thursday, so yeah. If you want to know more, it's, you can have even the architect working on this project.
Yes,
that will demonstrate it in detail.
And you've got all you need. And so managed VM is one way to host Docker containers on the Google Cloud, but also you can use a Google Compute Engine. Who knows Google Compute Engine? So Google Compute Engine, it's the VMs at Google, so IaaS. So here you just spawn VMs small machines, big machines, whatever, and you install all you need, all you want on the machines. And you can install Docker, or you can use the images where they already have Docker installed. And then you deploy your own applications the way you want. For example, me in production, I use Ansible to deploy my applications on the cloud. And so everything is written in Docker containers, but I still use Ansible to create VMs, deploy on the VMs, etc. There's another solution. You can use Kubernetes. Kubernetes is a cluster management tool written by Google in open source. The idea is you've got a cluster of machines. It can be machines in the cloud, VMs, or it can be machines that you host yourself. And then on these machines, you want to deploy Docker containers. But what you want to do is you want to describe what state your cluster needs to be in. So you say, okay, I want this image Docker to run on 10 nodes. I want this image to run on 20 nodes. And I want the images to be connected this way. And I want proxy on top of that, etc., etc. You just describe it into files. And then you say to Kubernetes, make it true. So it will just deploy containers on the machines and monitor the machines to make sure that the nodes are still running. If it's broken, it will recreate Docker containers, etc. So it's really a nice tool where you just say what your cluster should look like, and you don't say the steps to achieve this goal. So it's really declarative. Maybe you can do a demonstration. So here I'm going to show you. I created a small cluster of 5 machines. In fact, I used Kubernetes using a product that was announced last Tuesday by Google. It's a Google Container Engine. So it's managed Kubernetes on their cloud. So you just, with the command line, you just say, okay, let's create me a cluster of 5 machines. So I'm going to show you the syntax, but I'm not going to do it because it takes some time. So here you say, okay, gcloud, preview because it's a beta version. I want to create a new cluster called JUG. I want it to have 5 nodes, and it should be hosted in Europe. Okay? So when you do that, you wait a little bit. It will create 5 nodes plus a master. We create deploy Kubernetes on all the nodes, and then you're ready to deploy your applications. And deploying an application is as easy as having some kind of files like this. Here, what I'm doing here is I'm saying which state the cluster should be in. So I'm saying I'm going to deploy this Docker image. You've seen it. This is the one I use for my demonstration. I'm going to deploy it on one machine. Okay? And I'm going to map the 8080 port of this Docker container to the 80 port of the machine. And I've got labels so that on my big cluster of machines, I can find my services after I start them. Okay? So this is how I describe what the cluster should look like. And then I just run something like that, So here, I ask Kubernetes to run a replication controller, which will make sure that there's only one image running on my cluster, and I tell it where it should find the container. So let's do it this way. First time I do that, okay. So this is only the first time you do that. It will create keys to access to the machines. After that, it's faster. I tried to do it this morning in my hotel room, but the SSH access was closed. So what I've got here, it tells me that, okay, this image is deployed on the cluster, and it's running. So maybe I can have some more information. The command lines are a little bit long, so I don't quite remember them every time. So here I'm going to list the pods. So the pods on my cluster is a group of containers. Here my group is only one single image. But it tells me that it's running on node 3, and it's currently waiting. Waiting means it is downloading the image from the Docker Hub, and I can refresh to see what's going on. Waiting, okay. So I should have run it before. But when it's going to finish to download the image, it will be said, it will be written running. So running means that one node on my cluster is really running this process. But how do I reach this node from the outside? So here I can create what we call a service in Kubernetes. A service is another configuration that gives access to a group of containers that run the same image through a unique IP that is visible from the outside. And in fact, this is also described into a simpler JSON file where I say that I want to have all the nodes that have the label web to be aggregated on their port 80, and I want also to create an external load balancer rule to make sure that I've got an IP that is visible from the outside and that will load balance between all the images, currently only one. So I talk a lot, but in fact, I've just need 2 files, and that's it, and run 2 commands, and Kubernetes will make sure that everything is configured properly, and if sometimes one point of time it breaks, it will make sure that it is fixed. So here, it created my service. So I should find in my web console I should have somewhere a load balancing rule created with a public address. No. I love demonstrations. It's really nice. Where is it? Because I'm not on the good project. This is my production. Tac. Okay, so here it's created the web forwarding rule on this IP address, and now, of course, the demo is not working. Yes. Yeah, it's taking a lot of time to download the image from the Docker Hub, and this is, I think, the only problem I have every day with Docker, is each time you download an image on a fresh machine, it takes some time. It can be very long, because you can imagine that everybody is currently testing Docker and pushing to and from Docker. It's a nightmare. And so when you're deploying on the cloud, right now there's no better solution than pulling directly from the hub. Or you can host your own. Hub, but I don't do it for my demonstration. Come on. No, I can fail one demonstration, but not 2. Yeah.
Here it is.
Okay. So here, I deployed a Docker container on my cluster, and with a single line, I can tell the cluster to go from 1 node to 5 nodes, and the load balancer will react automatically, and that's it. That's as easy as this. So if you make the effort to package your applications into Docker containers, it's really easy to deploy on the cloud. It's really easy to deploy on your own machines. So you should try it, and really it makes you change the way you build your applications. I think Nicolas will talk about it later on, but you really start thinking about microservices. You really need to decompose your applications into smaller pods, and this is where tools like Kubernetes, so container engine, will help you.
So if you want to give it a try, but it's your job. You're the Google expert.
Yes, you can go to starter. You search starter pack Google Cloud Platform, and you use the code GD-in, and you have $500 to try things.
Including the container engine?
Including the container engine, which I think is available in alpha or beta, but I think it's open to almost everybody. If it's not open, you can still create VMs, install Docker, and make it work.
Fun, yeah.
Yep.
So you quickly talk about change on the way you design your application. A common way to consider Docker, that is more or less a mistake, is to consider Docker as a lightweight VM. It's so easy to tell, okay, I will start a Docker container, and then I will install supervisor D, so I can start my SSH daemon and my syslog and whatever I need, and then my application, and I have a dozen processes running. So somewhere replicate the init script of an operating system. So there is a theoretical rule in Docker ecosystem. It's that you only run one process per container. There is few exceptions to this rule, but you have to really consider it twice. So if we get back to the slide, there was a little lie here when I removed all the hypervisor stuff, that I didn't remove the small services that are running with my virtualized OS. I'm just running virtual file system and one process running my application inside a container. I actually have services running on the host that I could use, but sometimes I want to run my own, and Docker ID is to tell you if you need another service for whatever reason that your application will communicate with, just package it inside another container, run them side by side, and make them communicate. They will be fully isolated, so you have to enable this communication. Each of them can run his own image, has his own constraint, but then you are completely free. A typical sample, so I'm reusing a blog post from Jerome Petazzoni, he's part of the Docker core developer, is to use syslogs. So I have an application that is logging some hello to using the syslog API. And I'm also running another container that is running the syslog daemon, but not in daemon mode, just running inside the container, the plain process. And I'm using the volume mounting so I can share the syslogs socket from the syslog container to the host and then mount it inside my Hello application. So I can do some plain syslog from my application and have a syslog process to collect syslogs and could collect from many applications running on the same host.
The idea is really to compose small containers together and maybe by running a smart container that the syslog one you showed, you can enhance the other containers. And at the end of the day, you've got something that is complex but built of very simple things, simple containers that you can test alone and then you can test in the whole.
Right, because we used to create monoliths. Typically, a Java application is split into layers, technical layers, as a database one, a business logic one, a web layers. But from a functional perspective, there is just a monolith. Another approach called microservice is to do the same way you do on Linux, on Unix in general, that you take some very specific commands and just do one thing and do it well, and you pipe them, you compose them to do something larger. So you can do the same with your application, that introduce the need to make those small bits communicate together. The way you can do it with Docker is to use the link feature. You have seen that you can run a container exposing a port that you set explicitly, but you can also say to your Docker daemon, okay, start a MySQL database without anything open. Then start my Java application, but create a link with my already running database that we will name MySQL. And the web application container will run with an entry in etc-host that resolves magically to the database. So you don't really have to worry where it is.
Yeah, really, you really create small containers, and at runtime, you link them, and you say, okay, this one, I want to have access to this one through this name, and so in your container, you just have an entry, a DNS entry that points directly to the container. So it's very easy to link processes. I've got a demonstration. Maybe, I don't know if we can.
Sure, we can.
Sure. Yeah. And in fact, to do the demonstration, I will demonstrate two things: the links and something called Fig. I don't know if we plan to do it later on. I don't remember.
Yeah,
but
we do.
Anyway, Fig is a tool that is used to orchestrate multiple containers, because we've said, okay, you should have one process in one container. So then you should decompose your application into multiple containers. But Docker doesn't know how to run multiple containers at once. You can run them one after the other. You can link them manually. So then at the end of the day, you've got a huge bash script that runs all your containers. But if, let's say, your containers are really making a single application or a single pod, you should be able to describe that into a file. And this is what Fig does, and Fig was bought by Docker because they see that this is something they need to include into Docker. And in fact, I think that there's already prototypes of Docker start or Docker up running.
Yes, I don't remember the name of the command, yeah.
But let's see with Fig what we do. With Fig, I'm going to display it this way. With Fig, we create a YAML file where we describe all our containers. So here I've got two containers. I've got an Nginx container and a web container. The web container I will just build from sources from the current folder. So this is the exact web application I showed you before, where you can run Docker build and Docker run, and it will run. So I just say, this node, build it from sources. And this one, just pull this image from the Docker hub, map the 80 port to the 80 port outside. Let's map a volume. So here, I'm taking in the current folder, I've got sites enabled web, which is the configuration of Nginx. I can inject it into the correct place inside the container by doing a bind mount. And I link this container to the other one. So here it's the name of the container, here it's the alias. So the alias can be anything, it's just that on my Nginx machine, if I ping the machine Java, it will ping the web container. Okay, so here I decide to use the same name for the alias and the container. Okay. So here, this is one tool, there are many, one tool to describe a pod of multiple containers, and I can start them all at once. So what it will do, it will start my Java process on the 8080 port, it will start the Nginx on the 80 port, and the Nginx is configured to act as a proxy to the web. So let's see what it does. Let's try Fig up. Fig up will try to create both nodes. So one is it just needs to pull from Docker Hub, and one it needs to build. So that's the build part. I think it's a little bit long. But at the end, what I will see the aggregated output of both containers into my console. So I will see some outputs from Nginx, some outputs from Java application, and on my machine, on boot Docker, there will be an Nginx running on port 80 that acts as a proxy to my Java application. So now I can stop everything in one go. And it's described in a very simple file. Oh yes, I need to pull the image. Let's see how the network, how fast is the network. you want to add something during the download?
I have no jokes anymore,
no jokes?
sorry for that.
Maybe a question during the download? Or they all sleep? Oh no, one question.
Is there a way to ship a container on a media and not going through the hub?
Yes.
Is there a way to ship the container on a media, not using the hub to host it, doing a push-pull?
You want to answer?
Yeah. You can export all the layers of a Docker image as a tar.gz archive. I think it's Docker save, the command.
Docker export?
Docker export. I don't remember. I don't use it. But so you can just extract it as a binary, a full plain binary that you can install or maybe pre-install on your production servers, and then also server do a Docker load or import or whatever. So it's available in the local cache, and you can start your container.
Yeah, here it's really it's the binary side of Docker. So you export a binary that is self-sufficient, and you don't have to publish it. You just copy it somewhere. Or you can host your own registry, your own hub. So you can do that. For example, you will find there's a couple of Docker containers that are able to run as a Docker hub proxy, and they can store the images on your local network, local file system, or they can store your images on the cloud, for example, on S3 or on Google Cloud Storage. Google is working on providing the registry as a software, so you will be able to store your images on Google Cloud Storage just by using Docker push and not specifying the address of their service. So here I've got my two containers running. You can see that I really have the aggregated logs. So I've got the logs from the web and the logs from the Nginx. And when I open the web somewhere, local Docker, I have access to my application through the Nginx. So I can see Nginx acting as a page speed proxy to my web. So very simple to run a combination of multiple Dockers.
So something also new with container compared to virtual machines, it's the time to life for a container. A typical virtual machine, especially running in production, is something you will run for months, maybe even more. And that's the reason you are using some configuration management tool to install security updates and such things. In a container world, you can consider that a container can be restarted at any time, so you can start the new version at any time to replace the previous one. That's typically something you do with a blue-green deployment, that will just come with a new version of the application, start it on the cluster, and reconfigure your load balancer some way to route the traffic to the new version. So there is few patterns emerging around the way to manage such Docker infrastructure. Here is a typical sample. You have your application that needs to access some database, let's say a Redis server. So we had sample using just a link feature that lets you run both containers on the same host. But you know that one day or the other you want to separate them on distinct hosts. Don't want to re-implement all your code or application on routing. So the proposed pattern is that your web application is actually connected to an ambassador container, which role is just to route the traffic. This one is running on the same host as your application, so you can just link, and is responsible to go to the network to another side ambassador that is linked to your Redis server. So you decouple the network constraint. Another pattern is to use service discovery. So there are many tools about service discovery. Here is a simple way to implement it. That's to run your container with DNS configuration, so that you have a Sky DNS container that will handle all the DNS resolution. So each time you start a container, it will register it as I am web app 1, I am web app 2 to the DNS server. And this happens because you have a SkyDoc special container running with extra privilege that can listen to all containers starting. So it will make this DNS configuration fully dynamic. So that's a very simple way to say I can add new container to my application set of containers, remove them, restart them, and so on.
Because one of the problems with links that we showed you is the links are resolved at start time. So if you have a web app and a Redis, and the web app needs to connect to the Redis, if you stop the Redis and restart the Redis in another container, the web app won't find the Redis with standard links. So we need to have something more dynamic. And this is one of the solutions. The Ambassador is another one.
There is few other, including specialized service discovery tools that can handle it. A third pattern is about data, because so far we have talked about network, about way to move containers, but those containers have to access data on disk. So you can mount a volume from your host, and something that happens a lot in the Docker ecosystem now is that you will create a container that is just designed not to run actually a process, but to define all the volume mounting, and sometimes just to host volumes that are dynamically allocated by Docker daemon. You don't really know or don't really need to know where they are stored on the disk. And when you start your application or your database in this example, you will start it telling Docker daemon, run the Postgre image, but reuse all the volumes from this other container. And you can have other nodes using the same volume, so you can have somewhere of a shared directory. And during the Docker Global Hack Day, there was a contribution, an interesting one, that was using this pattern to do some backups. So you have your application running with such a volume, and it will connect to your volume container and do some backup on S3. So you can imagine there is few patterns to implement using this technique that can be very useful to a classic deployment.
There's really a meta pattern that you need to learn is everything can be fixed with another container.
Yeah, don't try to run a backup process as a cron in your application container. Run it outside. You have techniques so they can communicate or share volume or things like that together.
And the Ambassador is a container, the backup is a container, the SkyDNS is a container, the registry, the hub is a container. And so you just connect containers and they add features to the other containers.
If you want to know more, there is a talk this afternoon. I have no idea what this will be about, but it's improvising, so I will be there. The idea behind container is to implement what you call immutable infrastructure. That's clearly the opposite of the way you are running with Chef, Puppet, and such tools that try to maintain your host environment dynamically. So the idea is when you need to change anything, create a new version of the container and deploy it, and replace the existing one. So you always know the exact bits that are running, and you can reproduce them on any other host if you need.
This is a very important point, because lots of people, they read about Docker, they read about Dockerfile, and they say, okay, Dockerfile is just so poor compared to Chef, Puppet, etc. How can you compare these very complex tools that do a lot of things to make sure that your infrastructure is up and running, that it is exactly as it should be, compared to Dockerfile, where it's just a list of commands. But in fact, if you start to think about your containers as being disposable, that your container, they always build on something that you know that has the correct version, the correct files. If you just build on top of that, you don't need, most of the time you don't need these complex tools. But it's very complicated to forget about these tools, because we are taught that they are the only solution to fix all our problems. In fact, they can be used in other parts of our infrastructures. But Docker really does a lot of things very simply, and it's very efficient.
So, typical sample. Maybe some of you heard about some problem with OpenSSL. Did you heard about it? If you didn't, you have an issue. So what happens in such case when you have a heartbeat bug to fix in your company? In most cases, you will have a very nice weekend with a few dozen people that will have to stay all the night and upgrade all the application, upgrade the servers, upgrade everything, and we'll be happy if everything is up and running on Monday. In a Docker, in a container environment, things are a bit different. The host server itself probably has to be upgraded, but especially if you're running on an IaaS or in cloud in general, it's easier for you to say, okay, I will start new nodes with the up-to-date server. And then all the application you are hosting, you can tell all project team, you have, let's say, 24 hours to provide an up-to-date container. You can deploy it at any time, depending on your own constraint. Or if you are confident to deploy during the day, that's okay for us. If you want to wait for the night, that's okay for us. It's all yours. But after 24 hours, we stop the application. That's something reasonable. But then each team can provide its own fix, test it to ensure everything is okay. And some maybe will just plainly embrace immutable infrastructure and ways to just do running upgrades of the application, so they can do it any time. Some will wait from the night because it's easier to say, okay, there is few people on the service, so we can just stop for a few seconds. That's really easier to address.
With the tools I showed you, Kubernetes that deploys Docker containers on a cluster, you just change your configuration file and you say, okay, the image you should deploy, it's not this one, it's version 2. That's it. It will do a rolling upgrade of all your machines, waiting a given number of seconds between each update. And at the end of the day, your cluster is up to date.
And it works?
It works. I've seen it on Friday working.
Oh, okay, eventually. So far we told you that you don't need Puppet Chef and so on. And what will you do with them? Don't trash them. There is still some way to reuse them. A very common way I've seen so far is when you already have cookbooks to install all your stuff, is to say I will have a common Docker image that is designed to run Chef, but in Chef solo mode. That means I'm not trying to update a cluster, I'm just running my recipes on a single node from scratch. So I just reuse the powerful DSL to create my application in a specific state. And my product team will just say, okay, we start from this Chef solo image. We add our own cookbooks with all our Chef DSL stuff. And when we do a Docker build, it will run it once, create the image, the same way you can do with Dockerfile classic shell script commands, but reusing your DSL. And you have an immutable result. You don't try to upgrade it at any time. If you want to upgrade, just rebuild your image. But you can benefit both of the worlds. And the other way to reuse your existing tooling, that's what you are doing with Ansible, is to tell, okay, I already have a very nice tool that knows about my cluster topology, that can manage the replication of my web nodes and so on. So I just want to use the same. But I won't ask this tool to create some files, to upload some archive. I just want it to set up the Docker container. So you have the two aspects of those tools that you can really separate. One to build fine-grained image, and one to orchestrate your cluster. So let's move Docker in production. Yes, it's possible. Some people do it. You maybe heard already about Apache Mesos. That
who knows about Mesos?
A few of them. So Mesos is a cluster resource management. So you can execute tasks on Mesos, and tasks as defined are they're called framework, are plugins, and one of them can support Docker container. So you can ask your Mesos cluster to just host your container. Just give me some node. deploy my Docker container somewhere when you have enough resources to host it. You don't have to worry. There is a talk about it on Wednesday, so if you want to know more, I don't really know about Mesos, so I won't try to explain it. If you look at our previous slide about how you handle your application, you notice that we replaced all the service we need with containers, and we still have the OS services running. So the next step is to make them container as well. So we don't have any service running on the host system, but the Docker daemon. That's the idea of new operating systems that emerge today that are focused on container deployment. A typical one is Core OS. That's an OS based on Chrome OS. That means that it's designed to do some A/B upgrade. It has two partitions. One of them is active, the other is passive. And when there is a technical update, security update, it downloads the upgrade to the passive partition and will reboot, switching the partition. So it's atomic upgrades. So you wonnt have apt-get to fail just in the middle of an upgrade.
But it reboots the machine. So
yeah, by default it will reboot at any time, so it can be a bit embarrassing. It's using service discovery with etcd and systemd to distribute clusters. So the idea is that it's focused on clusters when you can say, okay, this node has to reboot because of an upgrade. So all the container that it's hosting will be moved to another host, so we can reboot it and then switch to the other ones. So that suppose that your application can be stopped and restarted on another node without too much issues. So it's a bit optimistic some way.
yes, but it's really the path of microservices, and if you decompose your applications into smaller parts, you should have something that works with CoreOS. So definitely you can give it a try, and it will make you a little bit of work up front, but then you've got auto-updating OSs, you've got the service discovery that is really useful for linking your containers on multiple machines. So,
yeah, and Fleet is a command line tool to manage your CoreOS cluster. So we already talked about Kubernetes.
It's really similar to Mesos.
More focused on
more
containers.
focused on Docker, on containers. But globally, I saw that Sam is calling his talk on Mesos the cluster operating system or something like that. No.
Not this one. Yeah,
Not
but
this
there's a talk about
Kubernetes. Yeah, it's really a shift where you need to think about your cluster as a big machine. A big machine that can run a lot of processes. Each process in the container, they are linked together, but maybe they're not on the same machine. But you don't care. You just have the tools to run processes, and they run where it fits. And you really start to think about your cluster as a whole machine. People like Google, they've been doing that for years, and if you don't do that, you cannot scale. You can scale up to a given point, but you cannot go higher. Because you won't have better machines. You will just have more machines.
It's not strictly speaking a requirement, but it's a very good way to consider those architectural principles for your application, because it gives you far more flexibility later. There is a lot more orchestration tools. We talked about a few of them. There is Figurewear. And talk about Maestro, GRD, NetPanamax, and yours, Consul, and there are probably a few of them more. Because if you read the Docker newsletter, there is more or less one new every week, because everybody has his own way to orchestrate Docker.
Yeah, have you got the slide with all the files?
The configuration files. That's another issue, because all of them have this more or less the same things to say. Which node will host which container ID with which parameter. So one of them will use YAML, the other one will use some JSON, and so on. And so it's really complex to choose one. You want something like that, you don't know exactly which one.
Yeah, it's really a jungle right now.
We already have seen Fig. So if you want to distribute Docker, as we already told, you can have private registry on Docker Hub. You can use your own Docker registry. You can load safe. That was the question we had earlier. There is also a project I've been using that is called Dogistry. It's more or less a proxy to your Docker Hub that will use S3 or file system to store. There is lots of options to explore.
In production, what I do is I rebuild from the Docker file. So it's a little bit strange because, as I usually say, my Docker file is like my chocolate cake recipe. I can give it to you, but you won't have the same cake at the end. It will look like, but it won't be the same. But for me, we deploy very often. And so we just copy the Docker file to the server and do a Docker build. The Docker build is incremental, so first time it's long and then it's fast. And this is our way to deploy with Ansible and Docker.
That depends a lot on the frequency of deployment.
Yeah.
When you are in production, you need to monitor everything that happens. So you can still monitor the process of your Docker container, but you want to have more detail on what's happening inside the containers. So you can have the Linux kernel level metrics about C groups and so on. There is a Google project named C Advisor that is designed for this purpose, that you run with some privilege on your Docker host, and it will be able to collect metrics from all the running containers and expose them with API so you can collect them. There is few dedicated Docker plugin coming to Nagios, for example, or classic monitoring tools. Here is just a screen capture from Roast Cake. That's a sort of thing you can have from monitoring your Docker environment. So you can see all containers with how they behave in terms of memory, CPU usage, and so on.
There are a lot of tools that try to work with Docker. And so once again, it's the jungle. So we'll see the best tools emerge one day, but right now you've got plenty.
It's really difficult to choose. What about data? Because so far we're talking about moving containers and so on. It's funny, but at some time we have to manage data. So you know that you can bind monde to volume. But when you want to move your container, as I explained on CoreOS, say the server needs to reboot, so no problem, just move your container to another host. Hey, my container has data on disk, I can just move this way. So interesting project is Flocker. It's using a feature from ZFS file system that can be used to do some snapshot of the file system and replicate them on other hosts. So as long as the file system is replicated and you can move your container, you can actually move your application more or less transparently. Sorry. That's the promise of the project. Now it's an early version today. Another funny project named Crew in the same context is that's to really move your container completely live. So you have your application running, you will completely freeze it. You can move the resulting binary freeze to another host and resurrect. That's a theory. I did not have seen it in action yet. But it's a funny project. At the end, you can imagine how the next generation of sysadmin will look like when they will just move containers because they restart a server. That will be a problem for them because it's being all the day with the hands here is a bit constraining, but it would be funny. So, the bad part. Let's talk about security. As a resume, Docker is not safe. There is an interesting talk on YouTube from the DockerCon that explains with lots of details the reason. Docker isolates your process in a container. That means you can't see other processes. You can access any file system that hasn't been explicitly mounted to the container. You can access sockets or network. But there is still points in the Linux kernel, in the file system driver that are not yet fully namespaced. So there is always ways to escape the container. There is actually ways to escape anything. You can escape a VM by hacking the VM, hacking the hypervisor, hacking the host OS. It's a bit more complex, but it's possible, theoretically. It seems to be far easier with a container anyway. So, don't panic. Few recommendations. Don't let your container run with all privilege as root and so on. There is no need for most use case to be root inside a container. There is no need to run with all the privilege offered by the Linux kernel inside a Java application. In Java application, you probably don't need to change your user ID at any time. So just drop those privileges. Treat all your container running root as if they were root on your host system. So you just probably won't allow anybody to run as root. Also learn about advanced Linux security techniques, SE Linux, Apache, and so on. That's a complex story, so I won't try to tell you more, but that's really interesting. And something that happened a lot in Docker ecosystem, when you search on the Docker Hub for some MySQL image, you will find hundreds of them. So you will pick up one, just start it, looks like a correct MySQL installation. Okay, let's put it in production.
And somebody's got your SSH key now.
Exactly. So Docker started to create what they call certified Docker image. So there is no prefix, you just do a Docker run Java, Docker run MySQL. The idea is that they are ensuring that everything is okay in building this image and everything is okay in the way the Docker file is created with some best practices. But if you want to do it for your actual company production, you probably will have a private registry with only image you created by yourself. Something we are waiting a lot in terms of namespace is the support for user namespace. That means that when you are root or some privileged user inside the container and for some reason you are allowed to escape, to jailbreak the container, you won't get the same user ID on the host, so you won't be root anymore. So there is some huge impact on Docker, but that will be a very interesting security announcement. And for the most paranoid of you, a very simple solution that gives you the possibility to still use Docker flexibility in terms of development, continuous delivery, reproducibility of environment is to keep your classic isolation layer, being KVM or whatever VMware stuff you are using for isolation of application, and just let them run containers. So for sure you will have to pay for two-level abstraction, but in terms of time to market for your application and efficiency or your build or software development process, it's a huge benefit. Right. So what's the next step in Docker ecosystem? So it's a time where we make some promise from the next version. So maybe tomorrow there will be a huge announcement that will just say the opposite we are taking today. So first thing we can promise you is huge adoption of Docker. Yeah. And not only on the cloud. On-premise is really a nice place for Docker to live, because that's where you have full control on what you are running. When you are a public cloud provider, like CloudBees has been for, just announced we stopped the service, but we had to run application from anybody, all on the same machines. So you can understand that from security point of view, it's really hard. But in your own company, honestly, do you think that some developer will try to hack the application they are building to be able to hack another application and add some extra bonus to their salary? Oh, yes. And if they can do that, I think it's fine, because they did a really interesting stuff. But anyway, I think really we will see Docker more and more.
And there's a lot of people asking me, my company, we invested a lot in VMs. Should I trash everything and use Docker? And the answer, you said, it's no, because it's better security to run your containers inside VMs. So you run lots of containers inside one VM. But also it makes it much easier to deal with your on-premise machines or cloud machines. So it's really a combination of both that is really useful, and that we're going to see in companies, and companies like VMware is investing a lot in Docker, in fact.
Sure.
So it's really you should really consider using both.
So Docker is trying also to extend a lot. The current way they are using this famous copy on write file system abstraction is based on IUFS on some Linux driver, not a device mapper for others. And there is some file systems that offer this feature natively, so typically BtrFS or ZFS. So there is some efforts to be able to use them with Docker. Because the current recommendation on which one to use is to use the one you have less bugs with, because they all have some drawbacks.
On Debian, I think we're using
AUFS, I think so, yeah. And CentOS is device mapper.
And they all have bugs.
And you can also already enable BtrFS. That is pretty good. Yes, there is always some drawbacks, so not so simple. There is also a large effort to extend the ecosystem of Docker implementation, not just focusing on Linux. So especially Solaris has the same concept of not strictly containers, but what they call Solaris zones that are more or less comparable. BSD has jails, and it's just a matter of implementing the adequate API so that the Docker daemon could reuse those features. And Microsoft announced a huge collaboration with Docker to have something comparable implemented in the next generation of Windows Server kernel with an API compliant Windows Docker daemon. So you keep the same tools, the same orchestration tool especially that are emerging today with your Windows infrastructure. But you will run Windows image on Windows, Linux image on Linux. This is still about sharing the kernel. Don't imagine you will be able to move everything everywhere. But that's already a huge benefit because I guess everybody here already had a huge crash on Windows just because you have opened the notepad, for example. You would like to have some more isolation. About tooling, the Docker daemon is the red brick and everything on the puzzle has to be created. So there is already some proposals, some interesting stuff. And the way the Docker team want to address it is using message communication. They created a library called libshan that is inspired from the Go language they are using for the daemon, but that can be implemented in other languages. So the idea is that you can come with your very specific tool for your own infrastructure, your own magical monitoring system, and can just plug into Docker daemon, communicating with it without with loosely coupling message-based integration. So it's a low-level stuff, and on top of it, they are working on something they call a lib swarm that is embracing the orchestration, but not just the orchestration. The idea is not to create the orchestration tool. The idea is to create the extension point and the collaboration API so that everybody can come with advanced Nagios monitoring and some very interesting logging service and some orchestration, Kubernetes or whatever you want, orchestration tools, and make them collaborate together. So the idea, yes, there is a, do I have, no, I don't have the slide. There is a little sample of it about logs. And I have said the simplest way for you to handle log is just to dump everything to the console. So the Docker daemon has a Docker log command that can be used to grab the logs for a container. And what libswarm is adding is let's say, a command log where any libswarm compliant tool can connect and collect logs from all the container, maybe aggregate them from various nodes, things like that. So lots of things to come, just the beginning. About security, because as I told you, when you do a Docker pull from whatever /MySQL, you are not sure what exactly is in. So it's about signing a container image so you are sure that you are actually running the one you expected. It's about the authorization you give to an image, and things like that. That's the next big point they are trying to address, not the most exciting one from a communication perspective, but they know they have to address this one. So if you put them all together, and you have a TGV on the slide, that's an official Docker slide, you have the next generation of Docker. Or you can expect so. We gave you some ideas on how to use your existing configuration management tools, either to orchestrate the cluster or to create the image. What I think is that there is a new set of such configuration management tools to emerge, and we have absolutely no idea how they can look like. So I just show you a picture from Final Fantasy, because you can pick up the one you prefer, and maybe the next tool will look like that. And the biggest effort is to imagine the future of Docker, because every week there is new pattern to emerge, new tools, new very advanced proposal. Recently there was a proposal to re-implement the network stack of Docker. Today it's really minimalist. There is some effort to introduce Open vSwitch natively in Docker, and there are people that are making proposals that really looks like OpenStack neutron philosophy to let you configure lots of patterns of communication with lots of huge flexibility in terms of how you want to implement your network to get container to communicate together, even not running on the same host. So things evolve really quickly, and it's really hard to follow.
Yeah, the challenge is with Docker, they managed to do a very simple to use tool that does lots of complex things. But for the more complex things, we have very complex tools. And so they're trying to, with LipSwarm, for example, they're trying to work with everybody to come up with a solution that will be a standard, that will be simple enough, but still gives a lot of flexibility. So extension points, plugins. The idea is, we've made a tool to run 1 or 10 containers. We need the tool to run hundreds of containers. And this tool cannot be built by a single person. It needs to integrate components from lots of people. So really, this is in progress. Everybody wants a piece of the cake, so we'll see how it goes.
So, and as we have some time, we can explore what we can do with Docker. Especially so far, we just run some server-side application, but you can do some more crazy stuff, including UI application, right? Are you confident with your demo?
Yes. Next demonstration to fail. So this one started more like a joke. I'm currently touring a lot of Java user groups to show them how they can develop on their machine without installing anything except Docker. So they don't have to install Java, they don't have to install Git, they don't have to install Maven. Everything will run inside containers. And I said, okay, can I run Eclipse inside a container? So I will show you. And then I will explain. So here on my machine, I will open an Eclipse that runs inside a Docker container. Don't do it. It hurts. and also it's a good opportunity to see all the failure logs that Eclipse outputs at the startup and that have no impact on Eclipse. So I don't know if it's good or bad news.
Yeah, you should do an IDA container, so it will be better.
Okay, so here I've got an Eclipse running inside a container. So how did I do that? So what I've done is I created a container based on Ubuntu. I installed Java inside the container, I installed Eclipse, and I installed SSHDmon. And in fact,
it's bad to have a
bad. So when I run my Docker container, what it does is it starts the SSHD, and that's it. And on my machine, what I do is I SSH into the container, and I do
X forwarding?
X11, do we say X11? I don't
Probably.
Know. I don't know how to do it.
X window forwarding.
X window port forwarding, whatever. I don't know how to say it in English. But X window port forwarding. So what I'm really doing is I'm exporting the display in my laptop on my host machine, but it's really running on the container. So I had to install Docker on my machine, and I had to install X11. Okay, so here I can see really Eclipse running inside a container. It's really awful, but it works. I can run a Java application. And I don't have Eclipse on my machine, I swear. Here it is. And I can still go to local Docker, port 8080, and I can see it running. And if I change, let's say, well, it works.
Great.
Okay? So everything is running inside the container. So you can run graphical interface applications inside a container. I don't know if you really want to do that, but you can.
So, okay, so there is another university tomorrow on the same room that will be, if I understood correctly, more focused on practical usage of Docker. So,
not this.
Feel free to come, and I think there is no overlap, so it will be interesting for you as well. And we have a few minutes for questions. And if you don't have question, you can vote for Okie Dokie.
One question there.
So if you have a war application, how do you update it now?
If you have a war,
Yes.
a Java war, you just build a new container with the new version of the war, and you swap container.
So with the build file, I have to put the war file into the same folder as the build file and create a new image.
Yes, you create a new image, yes. If you like Jenkins, your Jenkins will build new Docker images each time you commit, and then you just tag one and deploy it. If you don't like Dockers, Jenkins, sorry. Another question? Yes?
So what about external dependencies? So I'm creating an application that needs to talk with a web service somewhere, and I don't want to do that in my development, so I need another endpoint for that. But for production, I obviously need the correct endpoint. So do I have two containers, or how do I manage that kind of?
No, you can really parameterize.
Just to repeat the question. The question, if you have existing external system you want to communicate with, so maybe you have it Dockerized on your development platform because it's easier for development, but the production one is actually something you don't have under control. You need to connect to.
Yes, so you can really parameterize your container. So we've seen that you can use environment variables that you can set with a default value at build time, but then you can override at runtime. So they can point to different IP addresses, have different configurations. You can mount a volume that will override configuration files, so that in production you override.
I will recommend you try to mimic the way link command is working. That means that's the way you use it on your development platform typically. And on production, you will explicitly use --add host option to say what my container knows as web service is actually this IP, and what my container knows as environment variable web service _ port is this value that is passed by my ops team during deployment. So running locally with just link to my fake web service will have the exact same setup.
Yes, and in production you can have a real MySQL server not running inside a Docker, and maybe you want to run it inside a Docker in development. Other question? Yes?
Is it possible to a container to allocate specific resources like 1 CPU, 2 gigs of RAM?
Yes, can we constrain the resources allocated to each container? Yes. So you can give only a share of the CPUs. You can put a maximum on the memory. And in fact, when you run with Docker, by default, I think it's using like 256 meg. I think.
Exactly. Yeah.
I think it's using a small amount of memory, and it can use all the CPUs. But you can, with command line flags, you can.
Yeah, that's a common option, and you can configure Docker to run with LXC backend, so you can pass a full LXC container configuration that offers some more fine-grained tweaks to restrict the container.
I had a question. Let me ask you a question. Can we shape the network's throughput? Can we reduce the throughput allocated to each container?
I don't think so. There is, especially in terms of I/O, there is no yet some strict implementation of restricting containers. Same for accessing the volume on the host. You can't really tell it to restrict to some volume of data it can use. You have to use physical volume on your host, so they are technically limited.
Other question? No? Thank you very much for the time you gave, and you can come to us and ask questions if you want. Thank you.